Okay, so good morning, everyone. Welcome to our session. So the session today will be on real-world architecture. My name is Tiago Barbosa. I'm one of the FastTrack engineers for the Azure team working for Microsoft. So with me today, I have Will, working for the FastTrack for Azure team as well. And we have the pleasure to have Jamie Yates coming from Flybe to talk a little bit about his interaction with the FastTrack team and his own experience with our team and how we help them design their own architecture. Okay. So first of all, I'll start by talking a little bit about the session objectives. Then Will is going to walk you through some of the ways that we work with our customers on the FastTrack for Azure team, helping them design their architecture in Azure. And then he's going to cover some of the things that you should be doing when working with Azure, some of the general good practice, some design patterns that we typically see in that our customers should be implementing. So on infrastructure, application, and data persistence as well. And we will have some prizes at this point, so don't leave the room before that. Okay, so we have some questions, and you can win some prizes there. Then I'm going to cover some of the things you should be avoiding. So there are a lot of things that show up in a lot of customers, and we will give you some tips and tricks so you can avoid all of these pitfalls. I'll also walk you through some of the common anti-patterns here, and then we will have Jamie on stage to talk a little bit about his experience with the FastTrack team. In the end, we'll have some time for Q&A and some time to close the session, okay? So we have 4 objectives for this session. So the first one is basically to show you how FastTrack for Azure engineers work with customers and help customers architect and design their solutions so they can be highly scalable, available, reliable, and geo-distributed solutions when, of course, that's the case for your application. The second thing that we are going to cover in this session is we are going to share some proven best practices from our experience working with customers all around the world. So we are going to give you some tips and tricks that you can use, and hopefully you can take some of these learnings and implement them yourself. Okay. So the next thing that we want to show you, and we have Jamie here for that, so we want to show you how customers are actually leveraging the FastTrack for Azure team and other teams at Microsoft so they can basically get easier into Azure. So there are a lot of things that you need to think when you migrate to Azure, so we are going to give you a real world example of how that works. And of course, we want to inspire some confidence in your architecture design. So we are going to give you some of the learnings we got from the field, and we hope you can take all of these and implement it in your architectural solutions, okay? So last thing that I need to mention is that this is a level 200 session, right? So we will talk about all of these challenges. We'll give you some tips and tricks, but we will not necessarily talk about code, okay? So if you want that, we have a FastTrack for Azure booth downstairs, down in the expo area. So you can come there and talk to us. You can always book a session with us. So myself, Will, and probably 10 plus engineers that are there.
Follow the blue jackets.
Yeah, follow the blue jackets, right? So, Will, this is your time.
Thank you very much. Okay, so we'll talk a little bit about FastTrack for Azure and what the approach to architecture and how we look to build solutions with customers. But before we do that, let's just take a quick show of hands in the room for some audience participation straight off. So who here has actually had an engagement where FastTrack for Azure have helped you do something with your service? 1% maybe? Who in the room actually knows about FastTrack for Azure and had heard about us before you arrived here? That's not bad. It's 25%. So 75% of the people in the room probably just didn't even know what FastTrack for Azure was. So if you haven't put your hand up for the last 2. Okay. People who just put their hand up, we're targeting you today. Yeah. We want all of you down at the FastTrack for Azure bar later on. And hopefully we'll give you enough of a taster about how to work through in the real world architecture situations that you can't wait to come down and join us. Okay, so what do we do when we work with customers? And this isn't exclusive to FastTrack. This applies to a lot of teams within Microsoft, but we like to think we're subtly different in terms of how we approach things. So firstly, we'll kick off, we'll start to look with customers around what their architecture looks like. We'll go through any documentation that you have. We'll talk to customers and we'll go, let's apply our review and guidance framework. So we've got a bespoke guidance framework that takes in a number of aspects around different pillars of services, around different solutions, and we'll combine those together. If you take a look at the bottom left, so you can download the slides, you'll see it's open source, so it's up on GitHub. You can go and take a look at that, and you'll see the kind of things that we talk about, that we question, that we find, the kind of questions that we'll ask, and the kind of recommendations that we'll make. And they might be subtly different from the ones that you're used to, because they'll typically be around informing customers around one of these 4 or 5 pillars from the architecture center. So things like design patterns. If you're trying to do something that's already been done before, why not go and pick up an established way of doing it and apply that to the situation that you've got? Anti-patterns. So Tiago is going to talk at length of some of the things that we found in the past which you should not do. Things which, if you do them in any cloud environment, regardless of whether it's Azure or not, will probably blow up in your face in some way. And he'll tell you why. So we'll talk you through a couple of reference architectures. We've got a couple of slides on kind of where you start when you're going to begin an architectural design with Azure. So the world of Azure can be quite big and scary. There's a lot of different things and a lot of different services out there. And if you're not sure where to begin, it can be quite intimidating. So we'll help people walk through that road. Where do you start? Which reference architecture you want to start with? Best practice, everyone loves hearing that term. Yeah, we'll walk customers through how actually you can use these sessions. And then the pillars of software quality. So that's something which is founded by our patterns and practices team. We'll go through where those are and what those different pillars are in a moment. But first, a quick quote. Whenever we're discussing architecture with a customer, you're almost always going to hit a stage where there isn't alignment on what maybe people within the customer are trying to do or different teams within the customer. So there are some, not necessarily heated discussions, but honest disagreement. It very often forces people to think about the objectives and what they're trying to do with the solution so we can architect something which allows them to achieve the objectives that they've got. Frequently, we get people who come into us and they actually don't really know what they're trying to achieve. So they don't really know what they're architecting for. Are they architecting for reliability? Are they architecting for performance? Are they architecting for both? Yeah, and what levels do you need? What SLA is it? I'll drop into some of those in a moment, but there are 3 key pieces that we start to talk about. And number 1 being the purpose. So what is the solution going to do? What's its reason for being? And we tend to express that in high-level functional requirements. Agile processes are great as well, so you can express that in stories, in various tasks. But they tend to then derive into the success criteria, which is how does it need to do it? And from an architectural perspective, where you're designing solutions that run on Azure, this is the critical piece. If you don't know, in fact, let's take another show of hands. How many people have tried to build something without knowing what its actual requirements are behind the scenes? Yeah. How many people bear the scars of what happened when you tried to do that? Yeah, fair few shows of hands. So that's where we would encourage people to begin all the time. Yeah? If you don't know what they are, go back and find them out and challenge people, because you can't build a building without knowing what the building's going to be used for and what it needs to be sustained against. Yeah? How big does it need to be? How many people need to come through it? What does it need to withstand hurricanes? Does it need to withstand extreme temperatures? Those are the kind of things you think about when you're architecting a building, and software architecture in Azure is no different. Whether it's infrastructure or whether it's platform or whether it's software as a service, all of the same rules apply. You just apply slightly different patterns. And then lastly, we talk about stakeholders. So how many other internal or external customers might there be involved? Do we have an SLA commitment to meet with them? All of that arrives into business objectives of the solution, and that's the foundation of what underpins what we discuss. Above that, we can talk about the pillars of software quality, which we'll give you in a moment, or we can talk about functional aspects of the software, and we tend to address those separately. So we can do what we call a deep dive or a solution review, which will focus just on one aspect. So focus on maybe on your implementation of Azure SQL Database, rather than a high-level architectural review, which is the umbrella of your whole solution. So these are the areas which you would want to consider, and generally they assign with patterns and practices. If you go into patterns and practices, you'll see that those left-hand areas are very similar to what CAT and PMP put as pillars of software quality. We add a couple of additional ones within FastTrack, so the kind of other general observations. All of our engineers have been building software for quite a long time, working with other customers in other places. Sometimes we see things which aren't necessarily documented from prior experience. Cost design is a critical one. You architect not just to a performance level and a resilience level and a security level and potentially a deployment level, you also need to architect to hit a cost barrier. Really, any ISVs in the room? Anybody who sells software or builds services that other people consume? Yeah, so super critical for you guys, because if you get cost design wrong, you're not going to make any money from the service. Okay, so pop quiz. We've got some prizes. First one is a nice, simple one to get you into my English narrative of using a lot of double negatives all the time. But which of these possible approaches does FastTrack for Azure not do when we talk in design architecture with a customer? And we'll give you the 4. So do we not apply the FastTrack and guidance framework? Do we not default to a really awesome HA Uber architecture? Yeah, do we not use patterns and practices and reference architectures? Or do we not understand what the customer's trying to achieve? Yeah, okay, so can those people who had their hands up just keep them up for a moment? And we'll try and get some T-shirts handed out, yeah?
I think we don't have that many.
It's B, right? So, what do we do? What do we want to understand, and what's the general good architecture practice? So this is taking the next step. We've got our objectives, we understand what the system's trying to do and the customer's trying to achieve. Now we can actually look to make something tangible. We understand our goals, let's turn them into something visible. So where do we begin? My apologies for this. Can you see this at the back okay? Yeah, okay. So you might want to go and grab the download, but I will walk through these, yeah? What's not particularly important is what's actually in the small boxes. If you can read the middle box, then that's great. So we start at the beginning with the simplest and cheapest option that will get the job done from a reference perspective. And for those of you at the back of the screen, what's at the top left is a simple web app. Yeah, it's basically an Azure App Service app with a SQL database behind it. At the bottom left, that's a single VM on premium storage to give us an SLA. Simplest possible architecture and lowest cost. And then if we've got requirements for the system to be largely scalable, for it to maybe be tiered, maybe it's an N-tier application you're deploying, maybe it requires some infrastructure behind it that's non-PaaS deployable, or maybe you're looking to do a virtual data center implementation, we can start to add additional complexities in based on the requirements that we've got. So that middle stage is then at the top is a simple reference architecture. Again, it's a standard one that's up on our site, and that adds queuing, adds Redis caching, and adds a CDN to the web app. High levels of scalability and burstability. If we look to the bottom, that's an infrastructure-style environment, and that begins to add in multiple N-tier stages. So that's actually a typical design of a SharePoint farm. Yeah, but it will apply to any N-tier app that has database services behind it. And then if we've got a requirement for a super HA service, if this needs to be bulletproof, we'll start to add things in like multi-region, HA failover using Traffic Manager, for example. And then you'll start to see you've got, it is quite small actually looking at that slide. On the far right-hand side, there's a pair of yellow boxes, and that's a SQL Server always-on geo-distributed cluster. So that service would survive the loss of a single region and would just keep operating. Particularly poignant given the events that have gone on over the last month or so. So let's get that one out of the room to start with. The one at the top might be South Central. The one at the bottom will be somewhere else. Okay, so general good practice. We've banged on a lot about determining the requirements, but that's absolutely critical. You need to know what your cost envelope is. You need to know what those non-functional requirements are. If you don't, you're going to architect something which doesn't meet them. Yeah, and you won't know until something either failed or you deployed something which missed the target. You find your target and shoot for it. Okay, secondly, understand the Azure Storage Performance Envelope. Anybody see our keynote announcements around storage yesterday? Yes, a couple of people in the room. So understanding what those different tiers can do and what the boundaries of them are, effectively, we're at the stage now where you can architect any storage solution in Azure you want. Yeah, it's pretty ultra SSD tier, 160,000 IOPS per volume. That's big disk storage, very, very fast. Equally, at the other end, 500 IOPS per volume for standard storage. That's very, very cheap, reliable storage. And somewhere between there, you've got the balance for your solution that you're going to need. Yeah, so understanding that envelope and which tier you want to use is really important. Last up, scale out. So I can pick a bigger instance if I want to. If I just want to scale up, and I'm running a VM, or I'm running an app service, or something like that, and I just want to add an extra box, and I can stand a reboot of my service, that's great. I can just go in, go change it, and we get a bigger box. It'll reboot, it'll come back up. If I've got a service level that doesn't allow the downtime for a reboot, I need to scale the service out by adding multiple instances. Also, scaling instances out by adding multiple instances gives you another option in terms of cost. It allows you to scale them back in. So when the services are quiet, you can shut down the additional instances, and your cost baseline comes down to the size of the smallest instance that you've got, is the minimum. Yeah, and just simply add multiples of that where you can to add additional levels of scale to whatever you need or the maximum threshold of the service. There are very few workloads that need anything beyond the size and scale that a standard app service plan could do, which I think is 80-odd cores split out across 10 instances. If you need more than that, you can have multiple instances of that as well and do a storage stamp style approach. Okay, general good practice continued. We see a lot of people build out solutions that can't be load tested or are extremely difficult to load test. Consider how you're going to test and performance test and throughput test your applications at the very beginning. And normally that means we can expose some kind of API, or maybe we can do something with a browser stack to do some kind of web-based interaction or testing or automated testing there. But think about it. All applications are different in terms of what they look like and how they can be tested, but it's important that you're thinking about that. There are a couple of other key points we'll touch on, things like dependencies. So do you understand when you're building out a service what its dependency graph looks like? How many people have got a service? They've got a fully documented dependency graph, and they understand exactly which service calls each other and what calls off their service. One? Yeah, what? Sorry? Because you've automated the process of pulling it. Yeah, great. Yeah. That's the other way around. Yeah, you do it from bottom up. Yeah. But only one person, and they automated it. So if something goes wrong, you're going to spend a lot of time tracing which component failed. Why? Yeah, if you've got that ready, and a service goes down, you can be watching and monitoring those services, and you can maybe swap something else in or take action before your service potentially fails. And then lastly on this slide, architect for business continuity and disaster recovery. How many people have a fully documented disaster recovery plan for their applications? How many people have tested it? Keep your hands in the air if you tested it. Yeah? How many people were successful when they tested it? And how many people test that regularly and tested it within the last 3 months? So about 3 to 4% of the room. Yeah? And I know that one's a little bit disingenuous, right? So some people test on changes and maybe they haven't deployed it for 3 months, etc. But you can see a general rule there is that 90% of the people in this room don't have a tested disaster recovery plan that they tested inside the last 3 months or so. Yeah? That's critical, right? That's not something, and I bear the scars of that from an enterprise environment that had a recovery failure from an ERP system, actually a SAP system. That's absolutely critical. Write it down, document it, automate it if you can, and test it to death. So building out services away from kind of looking at the dependency graphs and what comes in, how do we know what we're going to build? Assuming that we understand everything now. So there's a number of different compute options within Azure. Starting from the left-hand side, we have lots of control when we deploy virtual machines and potentially virtual machine scale sets. Yeah, we're generally building pets with virtual machines, whereas with VM scale sets, we're building stuff with building cattle that we can tear down. As we go across into the right, the compute options become slightly more restrictive. Yeah, not completely restrictive, but slightly more restrictive. But they become more scalable or agile because we're managing them for you. And as we go across to the right in through to something like Service Fabric, for example, where we can do patching extensions, we can manage the platform, and you just deploy stuff to it, right into the very, very extreme examples, which would be functions, logic apps, Service Fabric Mesh. One. Anybody here interested in Mesh? Yeah? Anybody been down to see the product team on the expo floor? Yeah? They're down there at the moment. Head down and see them and speak to them if you need to. But, Mesh, fully managed. Yeah? Just give me something to run and let us run it. Same with functions. Give me some code. Let me run it. Logic apps. Give me a piece of designed logic, and we'll scale it out and run it for you. Looking towards that right-hand side really allows you to architect solutions much more quickly. Whereas looking to the other side, I realize it's actually to my left up here, but running virtual machine environments allows you to move legacy stack stuff. You can move stuff that you can't put into PaaS. Okay, so a few other patterns and practices that we mentioned. I'm going to go through a couple of infrastructure ones, a couple of app dev ones, and a couple of data ones, and then I'm going to hand over back to Tiago. But the infrastructure ones. So again, can you tell us, can anyone recognize all four of those? A couple of people. These aren't the only ones, they're key ones that we use. I think 2 people put their hands up, so let's blast through them quickly. Federated identity. So who logs on using either ADFS or Azure AD B2B into any kind of service? So every single person in the room at this point should have their hands up if you logged into the Ignite registration portal. Yeah, so when you went on and you logged on with Facebook, or for us an MSFT employee, which connects through AAD, you're using Azure AD B2C. Yeah. Yeah. I intentionally didn't frame the question as did you like the portal. Yeah, so that's basically you look at a pattern which is federated, so you didn't have to go and create your own accounts. You just had to tag them. Come back there. Gatekeeper pattern. So the gatekeeper is basically, I put a security instance, an instance of something which is dedicated only to security and nothing else. A reverse proxy layer, something like a WAF tier or an appliance that basically protects my application from attack. And if that externally facing instance gets compromised for some reason, you don't have the keys to my service because you're not running directly at the web layer or at the API layer. It's a very complicated diagram behind the scenes that you can see there, but actually that's all it really is. You stick something in the way, and then people attack that, and it doesn't hold any precious data. It's just responsible for forwarding and sanitizing requests. Classic example would be something like application gateway with our WAF tier. Okay, valet key pattern. Anybody using that for file uploads? One. Okay, so valet key. Instead of giving you a storage key so you can upload things, I give you a shared access signature, so you can only upload that one blob. Then I don't have to give the entire world my entire storage key. Yeah, and you'll see that implemented in a lot of ways. It's actually a security pattern to limit the attack surface of giving somebody a key, but it can be used in applications as an offload and performance pattern. Yeah, if I give you something that means you can upload this directly to Azure Storage, and all I have to do is give you a link that you can post at, your application doesn't need to maintain an open connection to a web server, and it will make applications dramatically more scalable that are handling long file uploads. And then lastly, static content hosting pattern. Did anybody see the announcements around Microsoft CDN? Yeah, so obviously we've had other CDN platforms for quite some time, so the Verizon and Akamai. But effectively, static content hosting pattern, you can either choose to just pre-render content, put it on storage. Yeah, that way you don't have to spend the CPU cycles rendering it every single time it gets displayed. Some people would choose to use output caching, or you can simply just stick a CDN network in front of your endpoint and let that just handle the caching and detail for you. Not appropriate in all situations. The highly dynamic sites have some intricacies there. But in general, static content hosting is a great way to reduce load on any hosting infrastructure. Okay, so next piece, we've got another prize set. So if I want to offload the overhead of writing uploads and downloads of blob table or queue storage directly to Azure Storage, which pattern do I need to understand? Is it valet key, static content hosting, federated identity, or the gatekeeper? Any hands up? Absolutely.
You're going to give me a hard time.
Yeah, go on. Just
these two. Well, anyways.
Again, guys, keep your hands in the air, please. Yeah, absolutely. Safe. So application patterns. So some of those had a kind of a bent into application, but in particular, there are some application patterns which we think it's really important to know. So the infrastructure guys, this is probably still quite handy to know because a lot of applications you will be hosting, will be doing this behind the scenes. Queue-based load leveling. If I've got workloads that do this in terms of spikes and troughs in load, a classic one for this is ticketing sites. Who's been in a situation where they've wanted to get tickets for an event of some sort, and they've gone, the tickets get released, you go there and the site's dead? Yeah? A couple of people? Yep. It's because they didn't implement that. If they implement that, the workload will stay roughly constant. You'll just get a message saying, you're in a queue, hey, your request being processed, it's going to take a little bit of time because we're experiencing high demand. Yeah? Until eventually the queue fills up, and then the site falls over. Yeah? So when that happens, we implement the second pattern, which is competing consumers. Yeah? So if I've got a really, really long queue, and only one instance processing it, the instance becomes the bottleneck. Simply add additional instances of the consumer, and those instances will compete for messages on the queue. They'll just grab the next one, and the other one will grab one, and the next one will grab one, and eventually that will come down. Really powerful in applications that can use auto-scaling. Yeah, so I normally just have one consumer, my queue gets longer, I add another load of instances, process everything on the queue, and then shut down the additional instances so I'm back down to one again. Really compelling way to make really highly scalable applications. It's not that difficult to implement. Again, all of these are up on our Patterns and Practices site. There are also examples in code of how to implement them. Okay, and then lastly, one thing that we tend to see people start to lean towards once they've done the top two is command query responsibility segregation. So, and that's around separating reads from writes. And you can write them to different models. So lots of people, when they design stuff, if we start to look at data patterns, you'll start to see things like contention between read and write models. So people have very, very highly optimized databases, usually, and normally they're optimized for read, because there's usually not that much write throughput. If you've got databases that need to do both high throughput reads and high throughput writes, the optimizations that you'll normally make to a database are different. So what makes sense is to have two stores, one that you write to, one that you read from, which are optimized for those methods. And you can even have completely different methods to write to them. One might be using entity framework, one might be using some kind of direct query methodology. Or maybe one's writing to something like an event store. Yeah? And we'll talk a little bit more about the event sourcing pattern in a moment, but something's writing through to events, and then when you're reading from a nice view which is cleanly optimized and has all the aggregations that you need. Okay, a couple of these around reliability and performance next. So throttling is a classic one. Anybody seen the situations where Azure Storage, if you put a single disk that has more than 500 IOPS through it, starts to see interesting performance characteristics? Yeah, one, two. Anybody on this side? Yeah, a couple. So that's because of throttling. Yeah, we design to a performance level of X. We state what that performance level is, and if you go through that request, we'll simply start to return, too many requests, messages back from the storage infrastructure. Yeah, you need to understand that pattern, to be honest, even if you don't want to implement it. But understanding that means that you can start to do additional things. So you can protect multi-tenant services from abuse by a single tenant, for example. I've got 200 tenants. You've all got separate keys. I use something like API management to throttle requests based on the incoming key. One tenant runs amok. We can throttle requests so they don't deny any service to the other users. Circuit breaker. So the opposite of the retry pattern. Retry pattern is really important to be able to know that things either work or don't work and retry them when you expect something to work again. Circuit breaker is the opposite. You use circuit breaker to say, I know that's down. There's no point in retrying that operation because it is never going to work. Wait until it's back up and then retry it. Nice one to look at the implementation actually up on the Patterns and Practices site, the source code. It sounds complex, that to start with. Should I retry? Shouldn't I retry? Should I fail over? Should I do something else? But there's a really nice implementation to talk through. And then we've got cache aside. Cache aside basically deals with how to do write-back caching in an environment which has multiple consumers. So I go and fetch my data, or I go and look in the cache first to see if the data that I need is present. If it's not present, I go and fetch it from the store and put it in the cache. So I write it in on query. Yeah? If something then writes to the original store, notify a consumer of the cache that the data's changed and flush it. So just knock it out from the cache whenever it gets updated. The effect of that is you'll never see stale data because the next request to go and read it will go and read it from the cache and put it back in there again for you until it changes, and then it'll get knocked back out. So you're only ever going to have one read for one piece of data until it changes. Really, really elegant way. It's used hugely with something like Redis cache. Okay, more prizes. So which popular queuing pattern is dependent on the implementation of another pattern as an enabler? Is it competing consumers? Is it circuit breaker? Is it queue-based load leveling, or is it throttling? This one's slightly more difficult, actually. You kind of needed to be listening to where we were going, okay? So a couple of hands over there. Does somebody want to call that out?
Okay, keep your hands up.
Yeah. So competing consumers occurs when you're seeing throttling based on the length of the queue, and you need to add additional consumers to process that queue back. Okay, so let's talk data. So again, quote from Satya, everything's connected to cloud and data, and all of this stuff is going to be run by software. Yeah? The software underpinning the data platforms, obviously, is software-based. What we do with data is software processing. Everything is underpinned by the data. Let's talk some data patterns. So polyglot persistence. Use the appropriate type of data store for the job. Yeah? There are teams within Microsoft who, quite frankly, probably won't particularly like people calling this out, but we do it because it's right for the customer. Yeah? You don't have to default to a SQL database store for everything, which is kind of the de facto choice when you put in web applications out there or put in ERP applications. If you've got a choice on the store you can use, have a look at the other options that are there. SQL is right in a number of scenarios where you need a relational database. But I've seen people putting blob data, for example, large binary objects into SQL tables, when all they needed is an index lookup against that blob. Well, blob storage is a perfect choice for that. You don't need to index across it. The SQL, in terms of the store, if you compare that in terms of cost with blob storage, SQL's up here, blob storage is down there. Yeah? They all have different performance characteristics, they all have different cost characteristics, and different scalability characteristics. The more you can keep out in terms of binary data of a relational store, the better. So document-centric stores, semi-structured stores, blob storage, data lake, what am I going to use that for? Document-centric stores, something like Cosmos DB in its document API form. If I'm storing JSON documents, it probably makes sense to store them in a store that's optimized for storing JSON documents. And then we've got graph stores, so the two icons we've got up there are for Azure AD's Graph API, and again for Cosmos's Gremlin API. If I'm storing information about relationships between people or objects, if I'm storing edges and vertices, it makes sense to use a graph store that's optimized for storing graphs. Or maybe I want to use more than one, and that's what polyglot persistence is all about. Having an adaptive model that can use the appropriate type of store for the job and can choose on demand what I want to use. Okay, so we mentioned earlier with CQRS and bringing data into potentially a different model for read and a different model for writes. I kind of hinted at events. Yeah, so I store something, I raise an event that it changed, I've got a reader that's capturing that data that's being written and writes it away to update a view somewhere that I can use for my application to read against. That model is called event sourcing. Yeah, and it's really powerful in that I can have multiple stores that can be updated at the same time. I can have multiple things subscribing to a change feed. Change feed in Cosmos DB is great for that, right? It's basically a log replay of everything that's ever been stored in Cosmos, and you can just subscribe to it, bang, 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 bang. I've got 10 stores, I need to keep them all in sync, subscribe to the change feed, write them out, job done. Yeah? Event hubs is also commonly used for something like that, or a service bus, to actually push stuff and serialize it across a queue. And then lastly, once you've got event sourcing, what we're really doing here is we're using a materialized view. So because I'm optimizing for query, I'm going to do pre-aggregations. Maybe this one, materialized view, is a really old pattern. Really, really old. It's just kind of come back to light in modern data warehousing and modern cloud analytics. Yeah? It's simply, give me a view which is optimized for lookups and aggregations of a query, but instead of doing that, executing that query at runtime, have the result of the aggregation pre-stored. And that could be an OLAP, cube, it could be anything which is cold path analytics, really. But you can use it in an application or just simply to speed up reporting in an infrastructure-style environment. Okay, so last comment from me, last prize. So which pattern would you use when you want to maintain a very fast store of custom query aggregations when your primary store isn't optimized for that? So is it A, event sourcing? Is it B, materialized view? Is it C, index table? Or D, microservices?
1, 2, 3.
Absolutely.
Yeah, Will?
Do you want me to take those ones now? Because
Yes,
I'm going to
I think
hand
it's your
over.
time.
Okay.
Yeah, so thank you, Will, for covering all of these best practices. So I'm going to walk you through some of the things that we commonly see our customers implementing, right? So these are, well, there are multiple things that we could put into these slides, but these are the most common patterns that we see customers trying to implement, right? So first of all, in talking about scalability, so one of the things that we see customers do multiple times, and this is kind of more on for application developers maybe, but basically people tend to share a lot of objects, and in terms of reusing code, it makes sense. But there are some specific objects that if you share them, you will basically end up with reusing TCP connections. You will end up having or ending up in TCP exhaustion. And in terms of scalability, you will be kind of limited. So an example for that is HTTP client. You have many other options there. So yeah, one of the issues we commonly see is this one. Okay. So another topic is a question that always comes up when we have our design review sessions with customers is, okay, so I want to reduce costs. So I want to share production environment with the quality environment. So and a perfect example for that is using the app services. So you know that we have these different deployment slots. So people see that, okay, I have the deployment slots. I can just swap between my production workloads and quality dev or whatever you want to call it. So can I use that? And we typically say, so, well, keep production completely isolated, because in the case of app services, you'll be using the same app service plan, so it's running on top of the same hardware. So if you are running load testing on your quality environments, that's something that you do not want to do, because you'll be impacting production workloads as well. So moving on and talking about performance. So one of the things that we actually see very often is people so I have a solution that worked very well on premises because everything was co-located, right? So now so my application is kind of slow. So we placed cache for static content, so using CDN or any other service. And we are also using Redis cache, for instance, for not so static content. So and one of the things that I actually recommend you here is that, so caching is not just, although in Azure you can just click a button and it's enabled, it's not that easy, right? So you need to have the right policies, the right eviction rules. Otherwise you will end up having stale data that you are sending your customers, and this is something that we see very often as well, okay? Yeah, so the cloud latency envelope. So we'll already touch this very lightly. So when you are working with and deploying your applications on premises, so everything, once again, is co-located, so you don't have to think about if it's going to be slow connection between your database and your front end or API. So you don't need to think about this. But when we are moving to cloud scenarios, and specifically when we have geo-distributed scenarios, you need to think about this. So your application needs to be aware that sometimes you may have a bigger latency because one of the regions is having some issue, or you have an issue on your application on a specific region and you are redirected to a different place. So if your application is not aware of these kind of things, you will end up having some timeouts in your applications, and that's why the patterns that Will mentioned earlier can help you do that. So prepare your applications for this as well. Okay. So in terms of resiliency, so Will mentioned early in the first couple of slides that typically customers come to us without even knowing what their application is supposed to do. So once again, go back and check that. And the other thing is the SLA. So if I ask probably many of you, so what is the SLA that you want to provide your customers in your applications? You will probably reply something close to 100%, right? So show of hands, please. Yeah, so ideally you would have 100%, right? So, but this is something that after a small conversation with the customers, you see that, okay, cost is a concern, or is a huge concern and they don't want to deploy in multiple regions. So, and they are using services that don't have the level of SLA, or we don't guarantee the level of SLA that they are looking for. So this is something that we advise you to look into, because so if you are looking for something that wants, if you want an high SLA and you are going to a single region deployment, yeah, maybe that's something that you need to rethink, okay? So also another point here is the lack of strategy for resiliency within services. So we do have a lot of services in Azure that we do all of this work for you already. So if we have redundancy, if it fails in one region, we can take care of that. But we have these global services as well. But your applications need to be aware of that. So take that into consideration. Use the services in Azure that already provide these features, such as Traffic Manager, geo-redundant storage. So all of these are already provide some kind of a resiliency for you. So leverage these services in your applications. Well, otherwise you need to implement all of these things yourself. Okay? So another thing here is the single points of failure, right? So even if you have low SLAs, you should not have single points of failure, right? So let's say that you have a virtual machine that runs a batch job that actually doesn't have an SLA, very high SLA. So if it doesn't run right now, it can run an hour later or 2 hours later. There's no issue there. But let's say that this is a virtual machine and the virtual machine goes down, and specifically on that day, you actually needed that batch job to run on that specific hour. And yeah, you are not prepared for that. So think about the SLAs that you are going for, and try to avoid single points of failure in your solutions. A very common thing that we see is on virtual machines, right? So I have a quote here. It's quite long, but basically the idea here is that you should always design your solutions for failure, right? Your solutions should be designed for failure, right? So, and you should have a recovery plan for that. And as Will mentioned, and I was very glad to see, and I was actually a little bit surprised to see a lot of hands in the air when Will asked for if you had well, backups and disaster recovery plans, and did you test them? So I was very glad to see some hands in the air, because typically what we see in the customers that we work with is that most of them don't have a major incident response plan. So if something fails, you don't know exactly how to proceed to restore the services. You don't know who is accountable for restoring the service. So this is something that you should always have in place. And if you don't, this is one of the things that I would recommend you having or working before moving to Azure, or when moving to Azure. Okay? So another thing around data is about data reconciliation and consistency strategy. So your applications and your services need to be aware that maybe if you have data replication into different regions, you may have some difference in the data that you have in these multiple replicas, right? So your application needs to work with this kind of thing. So it needs to be aware of these kind of scenarios. Otherwise, you would be expecting that all the data is there in every data store at the same point in time, and maybe it isn't, okay? So, and typically this is a mistake we see as well. So Will already mentioned, so your disaster recovery strategies, untestable. So you have a major incident response plan, but you have never tested it. You don't know if it actually works. I actually had an interesting conversation with one of our customers last week about this, and yeah, I said, yeah, I have the disaster recovery plan. Yeah, everything's working. And I said, have you tested it? And he said, yeah, well, actually, I haven't. So yeah, how do you know that it's actually working? Well, I don't. Okay, and that's one of the things. So it doesn't. So if you have a major incident response plan, it's good. But if you never test it, it's probably not working. Okay, so it's something that you should validate very often. So moving forward, so deploying in DevOps. How many of you are still deploying services manually to Azure? Okay, people. Okay, so this is one of the things that we always recommend our customers. So we have multiple ways of automating deployments in Azure. So you have Azure CLI, PowerShell, ARM templates. You have multiple tools that you can use to integrate and to deploy your services to Azure. So using now the new rebranded tool called Azure DevOps, or if you want to use any other third-party tool that you are already using it, so use it. This is something that we do see a lot in our customers. So lack of continuous integration. So everything is deployed manually. So try to avoid that. And also the lack of telemetry. We see that a lot of customers are not having any insight on the application itself. So they may get some insights on the infrastructure itself because Azure provides or because you are running some monitoring tools, but you don't have any visibility on the application itself. Right? So if something is going wrong with your application, and let's say you have a million users all around the world, and one user is having this issue, maybe it's time, or 10 users or 100 users are having this issue, maybe it's time that you fix it. Otherwise, you'll get this same issue probably to the entire users you have. Okay, so having telemetry will help you fix the issues before they reach every customer you have. So yeah, moving forward, so we have some of the anti-patterns that Will already mentioned earlier. So the first one here is the busy database. Okay, some customers tend to have a lot of logic running around on the database, which is not bad for some scenarios, but for other scenarios, so a lot of time is spent on the database. So for the user experience on the front-end side, your website is slow. Okay, your application is slow because there is a lot of work going on in the background on the database. So one of the things that you can do, and depending on the workload, of course, is to move processing from the database server to other application tiers that may be able to scale a lot faster. And as I said, there are some scenarios where having this work running on the database makes sense, others where it doesn't, okay? So then another anti-pattern here is the busy front end. So the busy front end is when you have a lot of work running on your front ends, and typically you can offload most of this work to other backend services, maybe even using or leveraging queues as well. So we do see still a lot of customers trying to bring all the code to the front-end side, and sometimes it doesn't make sense. You can offload this work to an Azure function or something like that, or even a backend service that you build in yourself. Okay. The third anti-pattern we have here is something that is very common as well, where people tend to get, well, every data that they need from a specific table, for instance, and in the end, they will not use all that data. So they go and grab all the columns of that specific all the columns and rows from that specific table, and this is just a large amount of data that will go into your services, and you will just, using a link query or something like that, you just throw them away afterwards. So why do that? So please just go and grab the information you need. Filter it down, grab only the things you need. It will make your services a lot faster. And the last one is something that we have recommended. We have been recommending for a lot of years. So blocking I/O is still an issue in some applications. So use asynchronous methods on your applications. This will allow some threads in the UI to be released to do other kind of work. So this will give you a better experience for your customers. Okay. So let me very quickly show you an example here of, and you can see this, right? So this is just an example of an architecture design we commonly see in our customers. Typically, when you don't have very high SLAs, or when you actually are not present in multiple regions. So basically we have this web front end running on app services. We have an API, and we have a database that is actually replicated to a different region, right? So what happens if the connection to, or there is something wrong with the database in the primary region, and we are redirected to the second region here in this scenario, okay? So I have just 2 samples here that basically they run exactly the same code, but the architecture is slightly different. So in this case, failover in this failover group, so the first database will start having some issues, so we'll be redirected to the second database. So we are using failover groups. And this secondary database is in a different region. So let me just go and start the test here. So I'm running the test for 20 seconds, and you can see the amount of requests that we are doing, okay? So we have total requests, we have around 70 requests by now, and the average request time is around, is around 300 milliseconds, right? So which is, yeah, we are going to a different region, so it's not bad, but still it has an impact on the latency. And if your application is not prepared to handle this kind of latency, you will end up having some issues. So doing this in a different way, okay, and we call it the right way, but this is something that you can go and grab directly from the architecture center. So this is in our documentation. So I will run the same thing. So in this case, we have Traffic Manager in front of it, which is basically working on the DNS level. And in this case, we have a failover region. So I'm going always to this, in this case, West US, if I'm not mistaken. So I'm going to that specific region. And if something goes wrong, I'm redirected to the second region, but my front end and API and the database will be there. So I will be, depending on where I am, I will have some additional latency, but not the same amount of latency that I have using the first example. So let me run this. You can see that using this scenario, basically I can make a lot more requests. So it's exactly the same code running, okay? And the average request time is a lot different. Okay? So this, a slight change in your design may, well, change a lot, okay? And let me go back to the presentation, and I guess it's you, Jamie.
Thanks, Tiago. Good morning, everybody. So my name's Jamie Yates, and I'm a data architect for UK airline Flybe. So this morning I'm going to talk to you a little bit about my experience architecting a data and insight solution on Azure. I'll tell you a little bit about the process that I went through, and we're going to take a quick look at the resulting architecture. So, but first of all, so who are Flybe? So Flybe are Europe's largest independent airline, and we fly around 8 million passengers each year between 81 airports across the UK and Europe. So we specialise in regional flying. Many of our customers are business travellers. So we've got a number of partnerships with other airlines such as Virgin Atlantic, British Airways, Emirates, Etihad, where our customers use Flybe services from regional airports across the UK to fly to the larger airports in the UK to fly further afield. So the challenge set for me was to architect a modern data and insight solution. And like many other organisations, Flybe was becoming a victim of the insight gap. So the insight gap describes a situation where organisations have more and more data, but they don't have more and more time to make sense of this data. And this was certainly the case for us. So we needed a solution that would cater for large volumes of data, both structured and unstructured, and allow us to take this data and put it into the hands of our business so they could use it to make data-driven decisions. So there are 3 main sources of data within an airline. So number 1, that's our customers, okay? So our customers make reservations, they participate in customer journeys, they create customer contact records and social media interactions. Number 2, our flights. So during our peak season, we operate around 500 flights per week. And this generates a large amount of operational data, including flight plans, journey log, and aircraft data from sensors. So number 3, our aircraft maintenance, repair, and overhaul operation is hugely complex and highly regulated by the Civil Aviation Authority, and they've got some very strict requirements around traceability. So there we need to retain huge amounts of data as well. So we've got all of this data, but our legacy data architecture is out of date. It's hosted on-premise in an aircraft hangar in the United Kingdom. And it's received very little investment in the past 10 years. In addition to this, we've also got an increased need for data governance with the introduction of the new European General Data Protection Regulations, which came into force in May 2018. So to allow us to start to address all of these issues, we started off by defining our data strategy. So the data strategy was put together to define our organization's comprehensive vision on how to exploit data. And it laid out the 4 following goals. So number 1, to put in place an effective data governance program. This would ensure that our data is stored securely and handled with great care, in particular our customer data. So number 2, we needed to control the flow of data between business applications and into data repositories. Now, largely due to the failings of the legacy architecture, we had a problem with shadow IT, and much of the data flowing around our organization was doing so with very little oversight or governance. So the 3rd goal was we needed to create a centralized repository of trusted business data. Far too much of our data was siloed in source systems, which had very poor capabilities around reporting and analytics. And number 4, we needed to get those tools into the hands of our business so they could use the data effectively. So with the data strategy in place, but it was completely technology agnostic. So the next step for us was to start looking at the technologies to fulfill the required capabilities. So our strategy roadmap spanned around 5 years, and we were able to identify technologies on Azure that provided everything we needed, from foundational things like data warehouse and data lake to more advanced capabilities around machine learning and predictive analytics. So Azure also provided a great set of tools that we could use as part of our data governance program, in particular data access control by Active Directory. But it also gave us a complete set of controls we could put in place so that we could limit and restrict data where required, ensuring that our data was stored securely. So our finance guys were really keen to understand the costs around the new technology, so we set about doing a financial comparison, looking at Azure against other cloud vendors. And it compared favorably, proving to be around 20% cheaper, but it also delivered some significant cost savings when compared to running our legacy on-hosted premise solution, when taking into account total cost of ownership. So finally, we also already had a little bit of experience in using Azure. So we'd previously migrated our flyby.com website onto the platform, and today Azure hosts our website, which serves 17 million users and around 176 million page views each year. So when I first started talking to Microsoft about building this solution, I was put in touch with Glenn Small, who's an engineer within their FastTrack team. So together, Glenn and I reviewed our data strategy, and we started looking at some of the technology choices we had made. We paid a particular amount of attention to the areas where there was considerable overlap between the services offered in Azure. A great example here would be our choice of data lake technology. And originally, we thought we were going to use Azure Data Lake Store, but having looked at our requirements, we realized that actually Azure Blob Storage is going to be satisfactory for our purposes. So making those choices early on within our project has saved us a great deal of time within the implementation. Okay, so as part of the FastTrack experience, Glenn ran a number of Skype sessions with our teams from BI and data and infrastructure. And this allowed us to look at different technologies, opportunities, and problems. I'd say these sessions were great for addressing people's concerns, remembering that our legacy architecture had been in place for many years. It ensured that all of the people within our delivery teams were comfortable with the design and technology choices. The sessions were also run in a very, very interactive way, and it would normally be one of the guys from our team interacting with the Azure portal, or perhaps reviewing demo resources. So just take a quick look at our architecture blueprint here. So this is probably quite familiar to those of you who work in this area. So over on the left-hand side over there, we've got our source systems, our business applications. We also interact with a number of third-party applications as well. And at the bottom, we've kind of got the wide world, where we take in data from industry organizations such as CETA and IATA. But we're also going to places like social media so that we can start to glean some insights into our customers. In the data management platform area, we got a number of non-Microsoft technologies around data integration, service bus, and file transfer. But we've migrated these onto Azure using Azure Compute and Storage. And they're hosted in the same data centers as our data repositories, ensuring that we've got low latency data transfer. At the bottom, we're using Azure Service Bus, and this allows us to decouple our integrations. It also allows us to serve up messages to multiple subscribers. We've done quite a lot of work in this area, mainly because we often find that we have different technologies incoming, and we wanted to bridge the gap So we're now, having done that work, we're quite ready to receive messages from any sort of messaging technology. Across in the data repository area, we've got Azure SQL Data Warehouse, and this really is the engine room of our data architecture. So with its massively parallel processing technology, it allows us to ensure that the data is served up to the end users very, very fast. Below there in Data Lake, we're using blob storage, and this provides storage for raw data, but also curated unstructured data, which we sometimes serve up into our analytics platform. At the bottom there, with Datamates, we're using a little bit of Azure SQL database, and here this enables us to put the data into the hands of the business, give them a data mart that they can control, and this enables them to do their own analysis, often enriching data from the centralized data repository with data that they've obtained from other places. So over in the analytics area, Power BI serves as the main front end on data within our business. We've received a great response from our business, having started to roll out Power BI. The things they particularly like are probably the ease of use, so things like quick insights and natural language data querying, where they can just generate a visualization very quickly and pin it onto a dashboard. Below there, we've got Azure Analysis Services, and we use this to host our larger and more complex data models. Again, the in-memory compute there allows us to ensure that that data is served up very, very quickly, ensuring good user experience. And at the bottom, we're using Microsoft R Open. So I personally think that the R language is a great data-focused language. It allows us to create advanced analytics routines. And thanks to the integration that Microsoft has put in place, we're able to actually deploy those into Power BI so they can be consumed by our general users. And we also take the output of some of those routines, push that back into the data warehouse so it can be used for future reference. So at the bottom there, we're using, helping with our data governance problem, we're using Azure Data Catalog, and this enables us to keep track of all of the data stored within our repositories, and it also allows us to line it up with business understanding through the use of the business glossary function they've got. So in conclusion, I think even though we're quite early into this, I think that this platform is going to give us everything we need to turn Flybe into a truly data-driven business. And I'll hand you back to Tiago.
Okay, so that's a nice summary of the FastTrack program in action with the customer, helping them go through architecture and what the end result was. Please come down and see us. We're not quite the end yet. We've still got some additional prizes to give out for Q&A. But come down and see us. We can help you build solutions on Azure, on the Azure platform, faster. And we can get your architecture right with you and set you up for success. So I'm going to go to Q&A just a moment. But that's cool. But please hold the question, definitely. Yeah, so we go through the discovery phase. That's largely what we talked about earlier on. We've talked about the solution enablement phase, which is kind of how we do the guidance. But there is also, product team, skin in the game from Azure Engineering to help make your solution successful on the Azure platform. I think we've gone 500 plus customers at the moment, developing and deploying on Azure. And there are certain regions that are engaged. So US is definitely one of them, Canada, Australia, New Zealand, UK, English-speaking Western Europe. And we're launching in new geographies all of the time. Please come visit us on the booth, which is there, the big red star. Yep, we do have a big sign saying FastTrack for Azure. But if you go and find the kind of centerpiece of the Ignite Expo area, coming from this side, walk past it, it's on the left-hand side as you walk towards the back theatre areas. We've also got another session on tomorrow, which is into more infrastructure-focused detail. This has obviously been talking very high-level patterns. If you want to get into the kind of areas around governance, around how to manage resources and deploy resources in Azure, it's another facet of FastTrack. Please go see that session. It's two of our colleagues presenting that. And we've tried something new for Ignite as well. So I'd encourage you to come down to the Azure Migrate classroom. You'll see a number of the guys, really, really specialist sessions. So we've got sessions going on around Azure Site Recovery, adding high availability. They're super limited in terms of attendance. There's only 15 chairs in the room. Yeah? Please come down and see. It will be standing room only, probably. I hope so, anyway. We're doing serverless in Azure, so architecting stuff for serverless. And we've got a really special one, which is completely random. So we're going to try a live architecture challenge. So Bring your architectures, bring your requirements, we'll go through them, and we will try and solution something for you live in the room with you, and we're going to see how many we can get through in half an hour. So please come along and join us for that. That should be good fun. Okay, so that's all at the Azure Migrate Classroom. Those are the different sessions that you can see. Obviously, the top one is us here and now. But please take a picture of that, because you won't see that one available anywhere else. And please come along and see us for these. And I'll hold that up. During Q&A, we'll hold that up. If anyone's got a question, please come up to the Q&A microphones. We've still got some T-shirts left. We haven't got many, and we're going to give those out for questions. Okay. Gentlemen at the front. Thank you. Okay, gentlemen at the front, go.
Okay, this is
It's the Q&A mic on. AV support. Yeah, good.
is it on now?
Are we on at the front? I got no. I'll tell you what, I'll repeat your question. Yeah.
So this is my first 10 minutes to one of these things.
Yep.
Are all the slide decks available on, I mean, I saw one that was on GitHub, I went there, and then there's other ones that there's out documentation, et cetera. And does it include,
So you can. Sorry, the question was around it being first Ignite. Can we get the slide decks available? So yes, the slide deck is available in the portal. There's a link in there to download the latest slide deck that we'll have uploaded, and it's the full version. The only thing it won't include is the speaker notes. The link should still be in there, and the links will go to both the Azure Architecture Patterns and Practices guidance, and they will also go to the GitHub repository where we publish our FastTrack guidance. Yep. So it should everything we've talked about is totally available and public, and we'd encourage you to use it as well, right? You know, if you don't necessarily need to have an engineer from FastTrack to follow the FastTrack guidance process. Okay, you got a T-shirt? Okay.
Let me check.
I work for Jet2 Airways. We also use Azure.
Yep.
So I have a question to the flight data architect.
Yeah.
Okay, shoot, we're all here to answer.
So in your architecture diagram, you have shown that
No.
data injection and the data storage and analytics work.
They are all large. I will probably ask you. So could you drop by our booth downstairs? You can ask us a question, ask for a chart. We have different sizes.
What we're using to integrate. So, like I said, it's non-Microsoft technologies. We're using the Talent platform, which we've had in place for a number of years. So we use it for application integration as well. We're also using it to load the data into our data architecture. It's got good integration with Azure. It works really well for us.
Check 1, 2. If we could please use the microphones because we are recording, that would be fantastic. Or at least repeat
using
your
what, sir?
questions.
Using the Azure Web Jobs or function.
I
Microphones
know, so
are
it's
up.
all being loaded by our data management platform. So that works.
Speak into it, you're
like,
tapping on it.
Database. So in terms of loading data into Azure SQL Data Warehouse.
Go ahead and talk right into the microphones.
Yeah.
Hi, we are undertaking a new adventure. We're starting some acquisition. That's going to be our use case going into Azure. And so we're actually working with Microsoft in a few weeks, so hopefully they have the same answer as y'all right now. But my question is like around serverless computing and all of this, is it advisable to take a company that we are purchasing and do an assessment and bring them, look at everything and say this should go into serverless, or should we do like what you started out saying, go simple at first, and then work into figuring all these things out and moving into serverless compute, et cetera.
Yep. Serverless can be actually easy, right? So it could be the easy way for your solution. So actually what we tend to do is look at specifically what you are trying to achieve in terms of scalability, for instance. So if you go serverless, one of the cool things about it is in terms of cost, you are in a consumption mode. So you only pay when your services are running, and you are able to scale a lot, and you don't need to manage that part, right? So it may make sense for your application. So you need actually to look into the actual application to advise you to go serverless or not, okay?
Right. I guess I missed the part that might help answer that is we're kind of on a timeline. And so it's like you take the time to dissect all of their current processes that we don't even know what they have, right? So do we just kind of do a lift and shift and then over the years move them into?
Yeah, so if you have a timeline, so if you have a tight timeline, so typically what we do is, okay, so we move it in, so we can move to virtual machines. If that's the case, we can move to virtual machines, and then we will modernize your applications as we go. We can help you in that path as well. So this is something that myself and Will, we do. We work on app modernization, so this is part of our job.
Hi. I have a question around availability of FastTrack for Azure. So first, whether it's available in Germany already, and the second question, are you only working with the end customers, or are you also having any collaboration way with like MSPs?
So we have, so you said, where are you based?
We are based in Germany. We
Germany.
have also a US sub,
Okay.
but the question is more
Yep.
how to work together with a managed service provider where we are working with the end customers.
Yeah. So we have a preview. We are working actually with Germany customers right now. So it's we only have few customers working with that we are working with, but you can let us know who you are, and we can help you get into the program. But we are working with Germany already, and yeah, and we have some local people there as well. But we are a global team, so if we have a customer in the UK, I'm based in Portugal, but I work with customers in the UK and any other.
So I'll come by and have a chat.
Okay, yeah.
I mean, what's worth adding to that as well, just for everybody else in the room in the context of working with a partner, is FastTrack will happily work alongside partners. So in fact, we will actively sometimes engage partners in the latter stages of a production deployment. Yeah, so we're more than happy to do that, and if there isn't a partner engaged, we're also happy to bring a partner to the table for you.
So like many customers, we're still largely on-prem, but there is a strong initiative to do a lot of stuff out in the cloud, and there's so many different ways to do things. Are there financial modelings where you can say, hey, I'm going to do this many transactions, and if I do it on a VM with this many cores and this much RAM and this much of this type of disk, it's going to cost this much, or if I just use AKS, it's going to cost this much? Because what everyone's dreading is okay, we got this all in the cloud, feel proud, and then they get a $10 million bill per month. Like that's one of the greatest fears that they have, is that they over-provision it because we don't know how much volume it's going to push. We don't know what we need.
Yeah.
Sure, we'd love to have everything, but it's like ultimately, if you build it, they will come. Well, they haven't come yet, so we don't know how much volume is going to be there.
Yeah.
Like, are there tools to help us with that? Because that's one of our greatest fears.
There are. There's a couple of evaluation tools, but the particularly useful one to take a shot in the dark at it, which stops people from just kind of going, it's going to be somewhere near $500,000, or it might be nothing.
Right.
That stops people from doing that is our price calculator, where you can just go and feed in types of compute or types of resource you're going to use, and it will actually produce you an Excel estimate that you can take out. And then you can fine tune that down. It's just persistent, it will store it. That's just simply up on the Azure site as pricing calculator. You can feed in, I want compute, I want storage, I want backup, I need networking, I need X, Y, and Z, and you can work out different models against that.
If FastTrack comes on site, will they take that into account when they're architecting?
So we do take into account cost balance and the cost design aspect when we're architecting. So sometimes we may advocate a solution for you, which is intentionally cheaper than the other solution you've just decided, which as a vendor and a commercial vendor is a bit of a weird place to be sometimes, but we do what's best for the customer.
Okay.
Yeah? If it's right for the customer, that's where we go, because we're engineering to your requirements with you.
Okay.
Yeah? So we do bear that in mind. What we don't do is give you a quote. We're not a commercial arm of Microsoft, we are engineering led. Yeah, so you need to take the responsibility for your own service, but we will help you take the cost actively out of it.
Okay. Oh, thank you.
Hi, my question is on Traffic Manager.
Yep.
You mentioned about performance. So this is related to Office 65 because we have so many users around the globe. And do we need to put the traffic managers on the cloud, or you guys take care of it for us?
So if the question is related to Office 365,
Yeah.
so we take care of that.
But what if we'll have hybrid identity set up on-prem, like ADFS?
Yeah,
Direct
so-
back to on-prem.
So if you've got an on-premise dependency introduced into Office 365, there are a whole wealth of patterns around actually how you can make that highly available. And there is guidance up on the, it's actually for the Windows team's guidance rather than necessarily the Azure team, but yeah.
Well, we do have high availability on-prem,
Yeah.
but we don't only have 2 DC.
Yeah.
With that cost performance issue in other geo, like for example, people coming from India, they have to redirect back to on-prem, like in US for authentication.
In theory, if that's where you pointed your ADFS endpoints,
Yes.
yeah, then that's where they will be directed to.
So how do we make it faster?
Yeah, so
Make a local ADFS there, or?
Well, you can have a distributed authentication system. That's quite a complex implementation, but it's certainly doable. That's one we should probably take for the FastTrack bar. It's probably not a session for the live Q&A. If you want to come and see us on the FastTrack Architect bar, so that's in the expo area.
Okay.
Yeah, come down and see us, and we'll grab a whiteboard and we'll look at what that might look like for you.
Okay. Yeah. Okay. Great. Thank you.
So a question I have is, how do y'all deal with management groups and multi-tenant, multi-AD?
Sorry, the question was, how do you
deal with with management groups and multi-tenant, multi-subscription?
So you've got subscriptions across multiple AD tenants.
Correct.
As a result, you can't put them in the same management group. Right?
Correct.
Yeah, I think the answer to that is actually that you don't. As far as I know, you'd have to have separate management groups in each tenant.
How do I move my existing environment up to each one of those? Do y'all have a way to, without federation, to have a single sign-on for each one of the subscriptions?
So the basic question for me there would be, what's causing you to have multiple tenants? Is there some kind of security requirement where you've got customers that cannot allow an internal IT team to deploy into certain parts of your tenant? Are you a SaaS provider or?
Well, the company we own, it's a marketing company. We own 192 marketing companies,
Yep.
and they contribute or they bid against each other, and so we have to keep them all separated.
Mm-hmm.
And so we have to keep them in different subscriptions, different tenants, because they're bidding against marketing groups. They're same.
So why do they need to say they can be in separate EAs but in the same AAD tenant?
Correct.
Yeah, and
They can't be in the same AAD tenant. They have to be separated.
and again, so if that's the case, why would you want a common management group across them?
Because each one of them has a different customer. Like they could have Ford, Chevy, and they need.
Oh, so they're customer tenants.
Yes.
Right, yeah, okay. So you're actually effectively like an MSP who's managing services on behalf. That's a really interesting situation, which I haven't heard described before. What we should do is get the requirement that you've got there drafted down in a little bit more detail, because at the moment I don't think you can do that is the answer. I don't think there is an answer to how you would do it. What we should do is take the requirements in more detail that you've got and get them into the hands of the both the AAD and the ARM engineering teams. Yeah. If you come and see us afterwards, we'll try and take that down, and we'll try and find somebody in the expo for you from one of those teams who we can talk to. Okay, so we're closing out about 2 minutes into overrun. Yeah. I don't see people walking around about to kick us out of the room just yet, but we need to be fairly prompt.
Yeah, but we can close and take the questions kind of.
Yeah, feel free to come over to the architect bar and ask us any more questions, and you can tail us across there as we walk if you like.
Yeah, okay.
Thank you, everybody.